Hi ladies, this is lesson 5.2. This lesson is talking about angles of a triangle. So first we have a new vocabulary term, and our new vocab term is equiangular triangle. So in the last lesson we looked at equilateral triangle, but this lesson is focusing on the angles of a triangle. And so this equiangular triangle means that all three angles in a triangle are congruent. All of the angles are equal. In this lesson, we're going to focus on this triangle sum theorem, and this triangle sum theorem says that in a triangle, all of the interior angles measure to add up to 180 degrees. So to demonstrate this with a model, just by drawing a triangle and labeling each angle of the triangle, each interior angle, a different variable, we can write this theorem out. And it says x plus y plus z is equal to 180 degrees. All right, let's look at this first example. In this first example, we're trying to find the measure of angle t. We don't know what that is. It's not marked perpendicular. We don't have a right angle marking. It's not marked congruent to anything. So we're going to use that triangle sum theorem. We know that all three angles have to add up to equal 180 degrees. So we're just going to write an equation for that. So angle t, we're just going to call t. You could call it whatever variable you'd like, but I'm going to use t because that's what makes sense in this particular problem. So I know that angle r plus angle s plus angle t have to equal 180 degrees. So I'm going to set those three angles, the sum of those angles, equal to 180 degrees. Then to solve for the measure of angle t, I can combine like terms, and I get 121 plus t is equal to 180. And then I can solve for t by subtracting 121 from both sides. And I get t is equal to 59. Now the question is to find the measure of angle t, so I want to make sure that I write that out. Measure of angle t is 59 degrees, because we measure angle in degrees. All right, let's look at our second example. And in this figure, we need to find the values of x and y. So we're still going to use our triangle sum theorem, but in our triangle sum theorem, we would say x plus y plus 55 is equal to 180 degrees, but we don't know x or y. So having just one equation is not sufficient. We need either the value of x and y, value of x or y, or some other equation. So first, if you look at this, you can see that angle BCA and that x, those are vertical angles. And we've learned that vertical angles are congruent. So I know that x has to equal 85. Now that I know x is equal to 85, I can use my triangle sum theorem to say x plus y plus 55 equals 180, but instead of saying x, I can say 85, because I know that x is equal to 85. And then I can solve for y just by adding like terms and isolating my variable. So 140 plus y equals 180. If I subtract 140 from both sides, I get y is equal to 40. And I know that's true because of the triangle sum theorem. All right, let's look at the third example. In example 3, we're finding the values for a and b. So this is similar to the last one. We have to think back to what we already know about angle measures. And I can use the triangle sum theorem, but not right away. Okay, I need another value first. So since I don't know what b is, but I recognize that 65 is adjacent to b, and 65 and angle b form a line, I can use the linear pair theorem to say b plus 65 is equal to 180, because I know that a linear pair is supplementary. So once I use that theorem, I can isolate b, and when I isolate b, I get 115 degrees. So B is 115. And now I know that 28-degree angle inside my triangle. I know B, and I just need to find A. So now is the time I can use the triangle sum theorem. And I'm going to write it out as an equation. A plus B plus 28 equals 180. But instead of saying B, I'm going to substitute my value for B, which is 115. So now that I know two of the three angles, I can use my triangle sum theorem and isolate A. And so I'm going to do that by combining like terms, and I get A plus 143 equals 180. And when I subtract 143 from both sides, I get A is equal to 37. We have another theorem in this lesson that is the acute triangles theorem. And this theorem talks about the acute angles in right triangles. This theorem says in words that the two acute angles of a right triangle are complementary. Complementary, if you remember, means that the angles add up to 90 degrees. So to demonstrate this in a model, I would draw a right triangle with x and y being the acute angles. And to write it out as an equation, I would say x plus y is equal to 90. So let's try a couple examples with this. So in this first example, I have the measure of angle A and the measure of angle B is what I'm looking for. And I see that these are two acute angles within a right triangle where the right angle is angle C. So I know that the measure of angle A plus the measure of angle B is equal to 90. I also have an expression for angle A. Angle A is 2x and angle B is 3x. So in order to solve for the measure of each of those angles, first I have to figure out what x is. So I'm going to rewrite my equation. Instead of saying measure of angle A, I'm going to say 2x. And instead of saying measure of angle B, I'm going to say 3x. So now I have this equation, 2x plus 3x is equal to 90. I have one variable. My variable is x. So I need to solve for that. So first I can combine like terms, and I get 5x is equal to 90. And then divide both sides by 5, and I get a value of x. X is equal to 18. So now I can take this value of 18 for x and substitute it in for my x value in each of these. So I'm going to go ahead and plug in 18 for x to find the measure of angle A. And I get 2 times 18 is equal to 36. So I know that the measure of angle A is 36 degrees. And then when I plug in 18 for x in measure of angle B, I get 3 times 18, which is 54. So the measure of angle B is 54 degrees. In this example 5, I'm looking for the measure of each angle. Now, I don't know what any of them are, but I know by looking at this diagram that they are all marked congruent. So I know that angle P is congruent to angle Q, which is also congruent to angle R. So I'm just going to call each of them X. You could call each of them P or each of them Q or each of them R. It doesn't matter, but I know that they're all the same. Okay, so I know that all three of them add up to 180 degrees, and I know that they're all the same. So I need to take that 180 degrees of my triangle and divide it equally among those three angles. So I get 3x is equal to 180 degrees after I add all of my like terms. And to solve for x, I'm going to divide both sides by 3. And I get x is equal to 60. So that tells me that the measure of angle P is 60 degrees, the measure of angle Q is 60 degrees, and the measure of angle R is 60 degrees. This triangle that you see, triangle PQR, that's an equiangular triangle, because in an equiangular triangle, all three angles are congruent. So we have this theorem, this equiangular triangles theorem, and this says that the measure of each angle in an equiangular triangle is 60 degrees. It has to be because there are three angles that are congruent and they have to add up to 180. So to model this in an equiangular triangle, I can name all of the angles using the same variable. And writing it out in symbols, I can just say x is equal to 60. All right, let's look at our last example. Oh, sorry, actually before we do that, I do want to mention that every equiangular triangle is also equilateral. Okay, so if you have a triangle where all three angles are marked congruent, you can conclude that all three sides are also congruent. And this stems from the isosceles triangle theorem, where in an isosceles triangle, base angles are congruent. And also in every equiangular, if every equiangular triangle is equilateral, also every equilateral triangle is equiangular. Okay, so the converse is also true. All right, in this last example, in your notes it says triangle ABC, but it should say triangle DEF. So it says in triangle DEF, measure of angle E is 3 times the measure of angle D, and measure of angle F is 9 less than the measure of angle E. We need to find the measure of each angle in the triangle. Very first thing you should do always is draw a diagram. Once you have your diagram drawn, you can then start to fill in some of the missing pieces. So first, I'm going to read through the statement, and I see that measure of angle D is 3 times D. So I'm just going to label angle E 3D. Then I can read a little further, and I can see that measure of angle F is 9 less than E. So I can fill in that angle as E minus 9. So I can write my equation using the triangle sum theorem as D plus E plus F is 180. But there's no way I can solve for each of those individual variables because I only have one equation. So I'm going to simplify a little bit. I'm going to put in 3D for E because it's the same thing. E is 3 times D. And I can plug in 3D for E as it relates to angle F. Then I'm going to take angle F and plug it in to my equation. So I'm just going to rewrite this now. I have D plus 3D, which is E, plus 3D minus 9, which is F. Okay, so I'm still using the triangle sum theorem. I have my 3 angles, but now they're all in respect to D. So now I can combine like terms, and I get D plus 3D minus 9 equals 180. And I get, when I combine like terms, I get 7D minus 9 equals 180. Now I'm going to solve for D by adding 9 to both sides, and then divide each side by 7. And I get D is equal to 27. So now I know right here, this angle is 27 degrees. So I'm going to plug 27 in for D in angle E. So instead of 3 times D, I have 3 times 27. And when I multiply 27 by 3, I get 81. So I know that the measure of angle E is equal to 81. Now that I have solved for E, I know that the measure of angle F is E minus 9. So E is 81. I'm going to subtract 9. And when I do that, I get the measure of angle F is equal to 72. So similar to system of equations like you've done in Algebra 1 and more extensively in Algebra 2, we're going to apply that same concept to geometry. So please jot down any notes or questions you have, and we can go over them next time I see you in class. Thank you.